Check this out. We've got something really fun today. This is so amazing. Oh man, again?
6.4b, Applications of Rational Equations. Steps. Number 1, define the variable as the answer to the question. This way, once you've found the value of the variable, you have the answer and you don't forget at the end to actually find that. Write any other values that you need in terms of that defined variable. Write an equation based on the information given. Solve the rational equation, check for extraneous answers, and answer the question with a sentence. This is so you don't forget to answer the question, and also so you don't forget your units. Example 1. Aaron and Andrea set off at the same time on a 30-kilometer walk for charity. Aaron walks faster, 1 kilometer per hour faster than Andrea. So she finishes the walk 1 hour ahead of Andrea. How fast was each girl walking, and how long did it take for each girl to finish the walk? Let x represent Andrea's walking speed. It's often beneficial to organize our information in a table for these distance, speed, time questions. Now, x is Andrea's walking speed, and they both went the same distance, 30 kilometers. Erin walks faster, so her speed is x plus 1. We don't want a new variable for her speed. We want to just write it in terms of the variable we've already declared. Now, time. Remember, speed is distance divided by time, and usually people see speed limit signs on their way to school, and they're written in, say, kilometers per hour or miles per hour, and that's kilometers is a distance divided by time, hours is a time. So you can use the speed limit signs to help you remember that speed is equal to distance divided by time. Do some algebra. Time is equal to distance divided by speed. Again, we don't want a new variable. We just wanted to write it all in terms of x only. So distance is 30, and speed for Andrea is x, and for Aaron, x plus 1. Now we need to make an equation. So we could say distance equals distance, but that's pointless. And we could say speed, Aaron's speed is 1 more than Andrea's. That's also pointless. So the real equation that we can make here is with time, and that involves the one bit of information that we haven't used yet, and that's that Aaron finishes 1 hour early. So let's make an equation. Aaron's time and Andrea's time. Now these are not equal yet, but we want to make them equal. And students often have trouble with which side to add the extra time to. So let's do this visually. Aaron's time is this big, just a random rectangle. Andrea's time is longer. She takes longer because she's slower. Okay, so visually we can see that this side is larger, this side is smaller. That means that we need to add the extra hour onto Aaron's time so that they're equal. So now we can use Aaron's time that we made in the table here, 30 over x plus 1 plus 1 extra hour is equal to Andrea's time of 30 over x. Now we might as well look at our non-permissible values here before we do any algebra. So x cannot equal 0 and -1. But from the question, we see that x is speed, and we're trying to go a positive distance. So really, x needs to be greater than 0. It can't be 0. Otherwise, we're not going anywhere, and it's also a non-permissible value. It can't be negative where we're going backwards, and we're never going to get to a positive distance. So there's our requirements. Now let's solve this rational equation, and we'll do that algebraically. I'm just going to take this whole equation and multiply by the lowest common denominator. There's an x here, and there's an x plus 1 family here. I'll multiply by both of those. Bringing those in, when I multiply, The x plus 1 family will cancel and we'll just be left with the x, so 30x. The next one, neither of them cancel, so we'll be left with x and x plus 1. And this one here, the x's will cancel and just the x plus 1 family will be left. Now let's distribute in. So we've got 30x plus x squared plus x equals 30x plus 30. Now on both sides we can subtract 30x and get rid of that. Let's collect up all the terms on this left side because I already have a positive leading coefficient for my x squared term. So I just need to minus 30 on both sides. There'll be nothing left on the right side. I'll write 0. Now we need to solve this. I can solve this by factoring, it looks like. So x plus 6 and x minus 5. And that means that x is equal to negative 6 and positive 5. And we've already discussed this. Negative 6 is inadmissible. Not allowed in this question, doesn't make sense. So the answer is 5. So Andrea's speed is 5 kilometers per hour. And Erin's speed is 1 more. She was 1 kilometer per hour faster. So hers would be 6 kilometers per hour. Now the question also said how long. So we also need to solve for the length of time. Andrea's time is 6 hours. And Erin's is 5. Example 2. John's family travels 300 kilometers from their home to a family reunion. His cousin Susan travels 200 kilometers in the same amount of time. Determine the average speed of both vehicles, given that one of the vehicles travels 30 kilometers per hour faster than the other. We need a variable, so let x be John's speed. And then we need to organize this information into a table. Like this. Now in this question, John's time is already equal to Susan's time. So we can just write 300 over x is equal to 200 over x minus 30. Now, some restrictions on our variable. X cannot equal 0, and it can't equal 30, because those are our non-permissible values. But also from the question, since x is a speed, we need our x to be greater than 0, because we need to get to a positive distance. Now let's solve this by multiplying each side by x. I'll get rid of it on this side, and multiply both sides by x minus 30, this x minus 30 family on both sides. And then we've got rid of our denominator. Next we can rewrite this, 300 times x minus 30 equals 200x. Let's divide both sides by 100, make it simpler. We got 3x minus 30 equals 2x. Multiply in the 3x minus 90, and add 90 on both sides, minus 2x on both sides. And we get x is equal to 90. That means that John's speed, because that's what we made x to be, John's speed is 90 kilometers per hour. And Susan's is 30 kilometers per hour slower, so Susan's is 60 kilometers per hour. The speed of a boat in still water is 30 miles per hour. It takes the same time for the boat to travel 5 miles upstream as it does to travel 10 miles downstream. Find the speed of the current. And this is assuming that the current is directly affecting the speed of the boat 100% upstream and downstream, which it doesn't in real life, but this is still a useful mathematical model. Find the speed of the current. Well, then let x be the speed of the current. And next we're going to organize the information from this question into a table. Like this. You see that the boat going upstream is slowed down by the speed of the current because it's like going uphill, and the speed of the boat is increased when it's going downstream, kind of like if it's going downhill. It'll go faster. In this question, the time going up the stream is equal to the time going down. So we can just set our two times equal to each other. 5 over 30 minus x and 10 over 30 plus x. Now multiply both sides by these binomials, or some people call this cross multiply. Okay, multiply by 30 plus x to get rid of this one. And on this side, 30 plus x. Now multiply by 30 minus x to get rid of this one. And 30 minus x. And you can do that in 2 steps if it looks too messy to do it in one. Now we want to multiply in the 5 into the binomial. So 5 times 30 is 150, and 5 times x is 5x. Same thing on this side. 10 times 30 is 300, and 10 times negative x is negative 10x. Let's collect up the x's on the left side here, so plus 10x on both sides, and minus 150 on both sides. That would make 15x on this side and 150 on this side. Divide both sides by 15, and we get that x is equal to 10. That means the current speed is 10 miles per hour. Shared work problems are common. Usually 2 entities are working on a task. You can't directly equate the times because they do different proportions of that task. So Raymond can do a job by himself in 3 hours. It takes Robert 2 hours to do it by himself. How long will it take them if they work together? Now, some people are tempted to just divide these times both by 2, but that's the problem. They don't do half the work each. Raymond takes longer, so Robert is going to do more than half the work. Here's how we're going to solve them, though. We're going to break it down into a rate. If the task takes a total of 1 hour, then how much do you get done in 1 hour? Well, you get done the whole thing. Okay? If a task takes 2 hours, how much do you get done in 1 hour? Well, you get half of it done. If the task takes, so this is 1, this is a half. If the task takes 3 hours, then you're going to get a third of it done. If the task takes 4, then a fourth. And if the tasks take 5 hours in 1 hour, you'll get done a fifth of it. If the task take x hours, you will get, whatever it is, 1 over x of it done. So this is the key. This is just a rate. If we break everything down into a rate, then we can add the rates. So Raymond takes 3 hours, and so in 1 hour, he will get a third of the work done. Robert takes 2 hours, so in 1 hour, he will get half of the work done. And together, in 1 hour, they will get whatever it is, 1 over x of the work done. And now we just need to solve this equation. 1/3 plus 1/2 equals 1 over x. Let's add these together using a common denominator. So 2 over 6 plus 3 over 6 equals 1 over x. This would be 5 over 6 equals 1 over x. And I can take the reciprocal of both sides here. So 6 over 5 equals x, or 1.2 if you prefer. That means that together it takes 1.2 hours. Now that makes sense because it took Robert 2 hours, took Raymond 3 hours, so together it needs to take less. We're assuming that this is a perfect world and they work together and they don't distract each other. When Khaled and Jared are working together, they can complete a job in 6 hours. One of them works twice as fast as the other one though. How long would it take if that person was working alone? So let x be the faster worker's time alone. So we have 1 over the faster worker's rate, 1 over x. Next we have 1 over the slower worker. The slower worker is going to be twice as slow, so 2x. And then this equals 1 over 6, the total time, or the rate together. Now we just solve this. So we can multiply, let's see, top and bottom here by 2. So we get 2 over 2x plus 1 over 2x equals 1 over 6. Now we can add these together, so we get 3 over 2x. And take the reciprocal of both sides, or maybe cross multiply, whatever you prefer. We're going to get 18 is equal to 2x, and that means that x is equal to 9. So the faster worker would take 9 hours working alone. This is part of algebra number 6, solving problems that involve rational equations. Try the questions out, see if you know what you're doing.